All right, welcome. In this video, we're going to be solving some absolute value equations, and we're going to be working through Algebra 2 Homework 3.1. And I think that, the first few of these is just like very typical, like solve the equation, and there's going to be an absolute value somewhere in it. So we know that kind of our set of steps is first we're going to isolate the absolute value on one side of the equation. Then we're going to say, okay, if the absolute value of a thing is equal to a positive number, then that thing is either the positive number or the negative number. And then we're going to solve two different equations. And if we get down to absolute value equals negative, then we will know that we have no solution, right? Because an absolute value of a thing can never be negative. It can only either be positive or zero. So let's just get to it. If the absolute value of this thing is equal to 9, then that means that this thing here is either equal to 9 or it's equal to negative 9. Okay, and I'm going to divide both sides by negative 3 and end up with 3 and negative 3. And then, I can just kind of mentally check my answer and think, oh, okay, I'm going to have absolute value of 9 equals 9, absolute value of negative 9 equals 9. That's true, right? Okay, so these are two solutions, and we're happy, right? Let's move on. Okay, already got it down to absolute value equals number, so that's when I'm ready to break it off into my two cases, right? If the absolute value of this thing is equal to 6, then that thing is either 6, or that thing is going to be negative 6. Okay. Either way, I can add 9 to both sides of both of these equations. And 9 plus 6 is 15. Negative 6 plus 9 is going to be 3. Then I can divide both sides of both equations by 3, and I'd see that x is 15 divided by 3 is 5, and x is 3 over 3, which is 1. Okay. I know that if it's absolute value equals number, I don't really need to worry about extraneous solutions, but I think that it's always good to just mentally check, at least if we're not going to write out and checking our work, making sure the equation's true, at least kind of mentally check and just make sure that we didn't make an error, because that can catch us, right? Especially on a quiz or a test where we don't have a solution video to go look at, right as soon as we finish the problems. You might be well served to check. So 15 minus 9 is 6, 3 minus 9 is negative 6. That makes sense to me, so I'm feeling good about my answer. Okay, this is the one where you can really get extraneous solutions with that 2x right there. So just be careful when you see absolute value, or with x inside the absolute value and outside. Those are ones that we really need to be careful on. Okay, so x plus 7's absolute value is 2x. Well, that means that either x plus 7 is equal to 2x, or maybe x plus 7 is negative 2x. Okay. I'm going to solve for this one. I might solve out in different ways. I might subtract x from both sides over here. And I might, add 2x over here. Right? We don't have to solve these the same way every time. Just solve it however you see fit. And then I'm going to subtract 7 from both sides. And then I'm going to divide by 3. Okay, and I don't really like the look of this solution, right? Because x equals negative 7/3, it's not going to work, because that would be us saying, okay, negative 14/3 is equal to the absolute value of x plus 7. I can just tell you right now that's not going to be true. We can look in and check our work and make sure, but for now I'm just telling you I can already see it's not going to be possible on a positive equals negative level. We'll look at it numerically here in a second. Okay, so we're going to check our work in pink. Okay, so x plus 7 is 14, so I'm taking the absolute value of 14. Is that equal to 2 times 7? Yes. Okay, good. X equals 7 is a solution. But when x equals negative 7/3, I've got negative 7/3 plus 7, which I'm going to call 21/3. Is that equal to 2x would be negative 14/3? Okay, no. Okay, this is positive 14/3, and if we take the absolute value of positive 14/3, it's still going to be positive 14/3, and that's not the same as negative 14/3. So this is an extraneous solution. I'm going to cross it out. Okay. Now over here, this next one, 5 times the absolute value of 2x minus 6 is 24. I'm going to try to calculate this. Now, I'm not going to lie to you and tell you that it's algebraically illegal to distribute that 5 in there against the 2, but I'm going to suggest that you not do that. I'm going to ask that you trust my judgment and trust me when I'm telling you that it's not in your best interest to distribute over an absolute value. Because whereas this 5 works, I think there are other things that we cannot distribute over absolute value. And it's best that we not get into what you can and can't, and instead just not, and solve for the absolute value instead. That's my advice to you. Okay, so 5 times the absolute value of 2x. I'm going to get rid of this minus 6 first by adding 6. And then I'm going to divide both sides by 5. And now that I've got it down to absolute value equals number, I'm ready to apply the principle that if the absolute value of this thing is equal to 6, then that thing is either equal to 6 or that thing is equal to negative 6. And then I'm just going to divide both sides of both equations by 2, and I'll be happy, right? I've got 2 solutions. And, you know, it probably might be good for me to check my answer. Yeah, this is going to be 5 times 6 both times, because you take the absolute value of negative 6, you're still going to get 6. So it's going to be 30 minus 6 equals 24 from both values of x, so we're happy. Or I'm happy. Hope you are too. All right, now this next one, I'm going to try to get at this absolute value of 4x plus 2, so I got to subtract that 8 from both sides. So 35 minus 8 would be 27. And then I'm going to divide both sides by 9. And then I'm going to say, okay, I've got it down to absolute value equals number, so I'm going to split it up. So that's 4x plus 2 equals 3, or possibly 4x plus 2 is negative 3. Pardon me. And I'm going to subtract 2 from both sides. Divide by 4. Okay. And we see that both of these equations satisfy at least this one. I can see that because it's like 1 plus 2 is 3, and negative 5 plus 2 is negative 3, and we take the absolute value of negative 3 and we get 3. But so yeah, I mean that's as much as I'm going to check those. It's really the ones that have x on the inside and the outside of the absolute value that we must remember to check. But you know, what are the odds that, you know, so the thing about the semester exam, I know I'm getting off topic here and you didn't tune into this video to see me pontificate, but think about the semester exam, right? Are you really going to remember that if you've got x inside and outside the absolute value, then you're supposed to check your answer? Or you think it's more likely that you'll just remember that if there's absolute values, you need to check your answer? Okay, that's why I blanket recommend we just check everything. Because it's really hard to remember when do you check, when do you not check, all that stuff. You should probably always check, right? Especially if you are really concerned with being correct, which I know a lot of y'all are. Okay, so let's move on. We've got absolute value equals absolute value. And when that happens, it can play out one of 2 ways. Either the 2 things on the insides of the absolute value are exactly the same, or the 2 things on the inside of the absolute values are exact opposites, right? Because the absolute value of 10 is equal to the absolute value of negative 10. We could say that, you know, the 2 things on the insides could be opposite while still having the same absolute. Or 2x plus 8 equals negative 10x. And from here, we're just going to solve the same way. I'm going to subtract 2x from both sides. Get x equals 1. And now I'm going to subtract 2x from both sides, and I'd get 8 equals negative 12x. And then I'm going to take x equals 8 divided by negative 12. And I know it's 4, 8, 12, so it's going to be 2/3. Okay, or negative 2 divided by 3. All right. And, you know, I'm probably best off to check these, but I don't foresee there being extraneous solutions in this because you're not going to ever be off by a sign factor, right? It's just absolute value equals absolute value. Nothing's going to be negative. Okay. All right, now number 7 and 8, these don't look different at all, but these are a little tricky. So I just want to warn you, and if you know if that's the ones that you're having trouble with, no judgment, right? These are the challenging ones. But you know, it would be remiss of me to not give you the challenging ones along with the easy ones and the ones that are very fundamental to what we're doing in this unit and beyond. So, you know, here you are. Here's your challenging ones. And you know what I'm also not going to do? I'm not going to put the challenging problems at the end of the homework because I don't want that person that's like cruising through the homework like, this is easy. I don't really need to do all of it. I'll skip the last 2 problems when those were the only ones that would have been interesting to them. Okay, so we're not going to do that. we're going to apply the same set of steps to this that we did to all the other ones. We're going to isolate the absolute value, get it on one side, and then apply our principle. So I'm going to add an x to both sides. And then when I drop the absolute value, that's going to incur a plus minus, right? Either x is equal to x plus 5, or x is the negative of x plus 5. Okay, from here I can say, okay, well this is like 0 equals 5, which that's not going to contribute me any solutions, so that's not helping, so I'm just going to ignore that now. X equals negative x minus 5. I could add an x to both sides, and then I'd have 2x equals negative 5, x equals divide by 2. I could write that as negative 2.5, because I've already done this problem. I did this one in class. And I found that it was easier to understand why it was true when we just write it as a decimal, right? When I take the absolute value of negative 2.5, I get positive 2.5. Okay? If I take 2.5 minus negative 2.5, that is 5. Okay, so that's a solution. I'm feeling good about that. Okay, and then maybe if I can remember to, I will, when we go to graph these equations, we can look at why this equation would only have one solution as well. I hopefully will remember to do that, because there's a few things that would make a lot of sense if I could graph some things for you, but we haven't graphed these yet, and I actually think that it's best to solve the equations before graphing, so we'll get there in a couple of lessons, right? Okay, now on this one, same story. I need to isolate the absolute value on one side of the equation. So I'm going to add an absolute value of y to both sides. And then I'm going to subtract 12 from both sides. Okay, and now I've got absolute value equals something. And I know that if the absolute value of y equals y minus 12, then either y is equal to y minus 12, or y is the negative of y minus 12. And then from here, I'm going to say, all right, that's 0 equals negative 12, or and that's not going to work for me, right? That's not going to give me any solution, kind of like 0 equals 5 didn't give me any solution. But it doesn't automatically mean no solution, right? So I'm not going to write no solution right under here, because that would indicate that this entire equation had no solution, but we found one. So it's just not contributing a solution, this side. For here, y equals negative y plus 12. 2y equals 12, y equals 6. Okay, but again, this is one of those equations with absolute or with a variable on the inside and on the outside of the absolute value, so we should be checking, right? We should always be checking. What happens when we plug in y equals 6? We get 6 minus 6 equals 12? I don't think so. Okay, so this is an extraneous solution. To check. Okay, y equals 6. 6 minus the absolute value of 6 is equal to 12? No. Okay, extraneous solution. Get rid of it. Move on. Okay. Let's see. Is this? No, that's not too blood-proof. We're good. All right. Here we've got a couple of more, and these look a little more exciting. And I don't know if they're going to be exciting, but they look a little different. Okay, so we've got absolute value equals thing, and that thing does have x's in it, so we're probably going to need to be careful. Okay, so either 10 minus 11x is equal to 4x, or 10 minus 11x is the negative of 4x. Negative 4x. Okay, and I'm going to just solve these for x the old way. I'm going to add 11x to both sides. Nope, not 10x, just 10. Okay, all of a sudden I'm making errors. So 10 equals 15x, and then we're going to divide both sides by 15, and I get x equals 10 over 15. I know 10 and 15 have a common factor. 5, 10, 15, that's 2/3. I'm happy. Okay, over here, I'm going to add 11x to both sides, but then I'm going to get 10 equals, I think 11 minus 4 would be 7x's. And then x is going to equal 10 divided by 7. So I divide both sides of that equation by 7. Now this one I know I need to check my solutions because I've got an x on the outside. So I'm going to check. x equals 2/3. That's going to give me, that doesn't sound promising, but whatever. Okay, have faith. 10 minus 11x. So 10 in terms of thirds is 30 over 3. Minus 11x would be 22 over 3. Absolute value of that equals 4x is 8 divided by 3. Yes, that looks valid to me. And then when x is 10 over 7, really looking forward to that. 10 is 70 over 7. Minus 11x, so that would be 110 over 7. Let me make sure about that. 11x, 11 times 10 over 7 is 110 over 7. Yep, okay, whatever. Equals 4x, which would be 40 over 7. Oh, sure enough, negative 40 over 7. We take the absolute value of it. It becomes positive 40 over 7. Okay, good. All right, happy. All right, let's move on to number 10. We've got these two things are equal to each other. So when absolute value equals absolute value, don't get distracted by the fact that there's a fraction. They're either the exact same or they're exact opposites. So I've got x minus 2 over 4 equals 2x plus 1 over 6. Or x minus 2 divided by 4 is equal to the negative of 2x plus 1 divided by 6. Okay. And we've dealt with some situations like this in this class. We're going to cross multiply. So we're going to have 4 times plus 1 equaling 6 multiplied by x minus 2. And we're just going to work this one all the way through instead of doing them side by side, because this is going to have some more steps. And I'm thinking I might need some extra paper too. Might not have left you enough room to solve this problem. Okay, so I'll go down until I don't have any more room. So this is going to be 8x plus 4 equaling 6x minus 12 when I distribute here and there. And I'm going to subtract 6x. It's subtract 4 as well. And then I'll divide by 2, and I'll get x equals negative 8. Okay. And then I'm going to cross multiply over here, and that'll work. Okay, so I'll have negative 4 times 2x plus 1 equaling 6 times x minus 2. So, in a very similar way, I'll have 8x and 4, except it'll be negative 8x minus 4 equaling 6x minus 12. Then from here, I might add 8x to both sides. Okay. And then I'm going to add 12. And divide by 14, and that would be 8 over 14. 2, 4, 8, 3 divided by 7, I think. Yeah, 3 divided by, wait, 2, 4, 8. 4 out of 7. 2, 4, 6, 8, 10, 12, 14. Yeah, 4 out of 7. All right. Now, I can tell that negative 8 is going to work because it's the absolute value of negative 10 over 4 is going to be the same as negative 15 over 6 is absolute value. And it's the 4/7 that I'm not totally convinced by. Okay. But I know it's going to work out. If you're not sure about this and you feel the need to check your answer, you're going to pull out a calculator, or you're going to, use whatever device you're using to watch this and go navigate to a calculator where it'll tell you what, if this is right or wrong. I'm going to move on. All right, if 7p minus 20 equals q, then what is the value of q minus 7p divided by 5? This question feels a little familiar to me. This feels like maybe something that could show up, I don't know, in a multiple choice environment. So I'm going to say, all right, q minus 7p divided by 5, absolute value, is going to be the absolute value of, well, q is 7p minus 20, minus 7p divided by 5, which is going to be, okay, well, 7p minus 7p is no p's, which 0 times anything is 0. So I've got negative 20 divided by 5, absolute valued, and that's going to be 4. Okay. And that one is a problem that's not super hard if you know what to do, but if you don't know what to do, if you've never seen it before, it might be kind of tricky. So I'm glad you've seen it at this point. All right. In a history class, students must give a presentation as part of their unit exam. Their presentation could be 45 seconds or within that time by 15 seconds. Write an absolute value equation that represents the minimum and maximum lengths of the presentations. This was something that I neglected to do in the notes, but I actually have not recorded the lesson video for this quite yet, so I'm going to make sure to put it on the video. The idea is that, okay, y'all know, and I was hoping that I made the numbers easy enough that you know that this means that the presentation can be between 30 seconds and a minute, right? And so, no, the minimum and maximum. It's 30 seconds, 60 seconds. So really what it is that within that time, that's the maximum difference between the presentation time and the average time, which is 45. So I'm going to say presentation time minus 45. Okay. But rather than saying that that's between two values or something like that, we can just say that to get the maximum and minimum, the absolute value of that difference is equal to 15. And what that means is that, okay, if presentation goes longer than seconds, this is going to be a positive number. Okay. But if it's short by 15 seconds, then this would come back negative. But we don't want to have like two different situations. We just want one equation to make that work. And that's where we take the absolute value of the variable minus kind of the center, the value you're supposed to have, equals the maximum amount of error, or, you know, amount you're off by, something like that. Okay. If the graph of y equals two absolute values of x minus 3 plus 4 passes through the points a and 12 and 1 and b, what are the values of a and b? Okay, this feels like something that's going to kind of wind down to a system of linear equations because we're looking for the values of a and b. And what we learned in the last unit about systems of equations was that if we wanted to solve for two variables, we need two equations. So I'm going to get my two equations by plugging in the point a and 12 into the equation, and then also plugging in the point 1 and b. Now I'm going to need some more color. Yeah, I've been working this whole homework in pencil, and that's just not doing it. So let's start off with a and 12. Okay, that's a point that's on the graph, which we don't actually know anything about yet, but we will soon. So I'm going to plug in 12 for y equals 2 absolute value of a minus 3 plus 4. Oh, so it might be a little tough to solve. Okay, and then the second thing is over here, 1 and b, I'm going to plug in b equals 2 absolute values of 1 minus 3 plus 4. Yes, that's how we're going to find. Oh, no, it's not actually a system. We're just going to, solve these equations. And A is going to be a little harder to find than B. B, we're just going to compute forwards, right? That'll be easy enough. So this is 2 times the absolute value of negative 2. So that's 2 times 2 is 4 plus 4 is equal to 8. And then over here, well, I've got, just thinking about how I could have worked this or how I could have written this problem a different way to make it, even more exciting. But I think this is exciting enough. And so I'm going to try to solve at A, right? And so I'm going to try to do the same steps I've been doing this whole time. Isolate the absolute value, apply logic, solve, right? So I'm going to subtract 4 from 12, and I'm going to get 8 equals 2 of the absolute value of A minus 3. And then I'm going to divide both sides by 2, and that's 4 equals the absolute value of A minus 3. And if the absolute value of a thing equals 4, then that thing either equals 4 or it must be negative 4. Okay, so that means that A minus 3 equals, and I haven't done this at all in this video, but I know that this is a way that a lot of people solve these absolute value equations. They just bring in a plus minus. And so if I wanted to solve for A, I'd go back over here and say A is 3 plus or minus 4. Ah, yes. And so this is the first piece of evidence that you're seeing that the graphs of these things are a little weird, right? That we could have two different x values going to y equals 12. Okay. Now we should definitely expect it to be a function in the vertical line test sense of the word. So there shouldn't be more than one y, more than one b that corresponds to x equals 1. But we'll see more. We'll talk more about this in a couple of times when we go to graph these things. So 3 plus 4 is 7. 3 minus 4 is negative 1. So whereas b must equal 8, a could be 7 or it could be negative 1. Okay. That was an interesting one. All right, if k is a constant, y equals the absolute value of kx plus 1 minus 3, passes through these 2 points, what's the value of k? All right, I think what we're going to be able to do is plug in for x and y on these, using one of the points. We'll get k down to one of 2 different options, and we'll check it against the other point. That's my plan, at least at this point. Although, I'll be honest, I have not worked this problem yet. I don't know how it's going to go. So, all right. I'm going to plug in negative 1 for y. I'm just going to do 2 negative 1 for my plug-in, and then negative 4 for checking. Okay. So negative 1 equals the absolute value of k times 2, which we might write as 2k, plus 1. Minus 3. So I'm going to add 3 to both sides to isolate that absolute value. So that would be not 4, that's 2. Equals the absolute value of 2k plus 1. Okay. And if the absolute value of this thing equals 2, then that thing needs to either equal 2 or negative 2. So 2k plus 1 equals 2, or possibly 2k plus 1 equals negative 2. Okay. And then I'm going to say, okay, I'm going to subtract 1 from both sides. Subtract 1 from both sides. Divide both sides by 2. Okay. And then I'm going to have to check against, negative 4 and 4. So what I'm thinking is, I'm thinking about how I want to do this because I did not think about it before I started working the problem. I think I'm going to plug in negative 4 and 4 into the equation that I'm using to check. And so I'm going to say 4 equals the absolute value of k times negative 4 plus 1 minus 3. Yeah. And then I'm going to kind of get it down to where maybe I can check visually. Okay, I'm going to add 3 to both sides. Yeah, so that's going to be 7, equaling the absolute value of negative 4k plus 1. And so we need negative 4k to equal positive 6. Or, maybe like negative 8, right? But I see how it's going to happen. It's going to happen with this one, right? Now, what I might do, if you can see it there, feel free to be like, hey, this is my answer, this is not. If you don't see what I just did there, then what you're going to do is you're going to solve all the way down for k. So if the absolute value of this thing equals 7, then negative 4k plus 1 is either equal to 7 or negative 4k plus 1 equals negative 7. So I can subtract 1 from both sides. Negative 4k equals 6. K equals 6 divided by negative 4, which is negative 3 halves. Or over here, negative 4k equals negative 8. K equals 2. Okay, and so the one that's common to both of these is k equals negative 3 halves. So k equals negative 3 halves fits for both of these points. So I know that this is my answer, and these are not. Okay, because if k was 2, it wouldn't fit the first point, and if k was half, then it wouldn't fit the second point. Okay, that was an interesting problem. I liked that. If you had problems with that, come see me in the morning. I would be happy to discuss that with you because I really think that now that we've seen it, that this is a problem that we could repeat. If we had success on it, we could repeat our success on it. But if we didn't have success on it, come talk to me and I feel like I can lead you in the right direction to get you there. Okay, that's going to be all for this video. That's all the problems for homework 3.1. Really, thanks for watching. I hope this